When we are comparing rates on linear representations, that's just a way of saying, look, we're going to use tables, we can use graphs, we could use linear equations, different ways to compare the relationship between our x and our y. And so to compare their relationship, the change of what is happening over time or over whatever, the change that happens consistently, okay, it's proportional. So every time your y does something, your x does something, or you say x does something, y does something. And that relationship is the slope. Okay, so you can see that inside of an equation, like y equals x minus 4, the slope is the number in front of your x's. Okay, if there is no number there, you're assuming that the slope is 1 right there. Okay, and then see if I can clean that up a little bit there. It looks a little blurry to me. So it says which relationship below, see if I can get, come on, let's do a better job here. There we go. Which relationships below represents a function with a greater rate of change than the function y equals 1x minus 4. So they didn't put the 1, so that's a little tricky. If you want a greater rate of change, well, what number is bigger than 1? Well, lots of numbers are bigger than 1. So basically we have to pick a number bigger than 1. So what's that going to look like? We have to be able to identify the slope on these different graphs. Now they walk through on the following pages one at a time and show you. So I'll do a little mix of explaining it and then showing you how they've got it expressed as well in the explanation, which I think they do a good job of laying that out. So my rate of change is my y over my x. So what's my elevator and what's my run? So if I go up and over, I go up 1 over 1, up 1 over 1. Well, my slope there is 1 over 1. That's 1. That's equal to that. Okay, so not different, equal. This one, I can tell you right now, it's going to be negative. It's going to be a smaller number, so it's going to be, it's not going to be bigger than 1. Okay, my slope is going to go down the elevator and over. I think it looks like down 4 over 1, maybe down 5 over 1. So either way, we're going down 5 over 1. That's down -5. It's -5. This one takes a little bit longer to look at because you're going to look at your y over your x, or in the changes that would happen each time. These are different points on a graph. And if I would compare them, if I do y compared to y, if I look at this change here, we went up by 20. Okay. This one also went up by 20. This one went up by 20 each time. We went up by 4 here. We added 4, we added 4 again, we added 4 again. So it's a nice consistent relationship. Well, the change in my y over the change in my x is 20 over 4. 20 over 4 is 5. So that's another one where the slope was 5, or this one was -5 up here. Okay, -5 over 1, same thing. This was a +5. And then we can look at our changes here. We're going lower and lower and lower, upper, upper, upper. So this one is going to be going down by 8, down by 8, down by 8. And you can plug those in the calculator. I know I'm a little faster because I'm a math teacher, but I want you to get the idea and not get caught up in the details at the moment. 3 plus 5 is, or 3 plus 2 is 5, plus 2 is 7, plus 2 is 9. Again, so we take the change in our y over the change in our x. This is our elevator. Took it down 8 flights. Then we ran to -8 over 2 is going to be -4. So which one of these numbers is going to be bigger than 1? Well, that's equal to 1. That's less than 1. That's less than 1. This C was the only one that was bigger than 1. And so that would be the one that had the only rate of change that was greater. Okay, so they walk you through that. They tell you in your first example that your rate of change is 1, and they show you how to find that on A. They show you that 1 over 1 is 1, your elevator over your run. B, they show you that it's -5. This can't be B. So you're eliminating your options. Here we look at the change in our y's over the change in our x's, and we divide, and we get 4, or excuse me, 5 to simplify. That is it. That's our answer. But just for good measure, they go ahead and show you the other way as well. But C is going to be the final answer for that one. I got to jump up and make my room light up again. Hold on. Okay. So then on this one, same idea, same thing, except this one they say we want to have one with a lesser rate of change. So we want something smaller than 1/4 in that equation. So they're just getting you used to all sorts of ways of comparing these numbers, making sense of what this whole rate of change thing is, slope, it's got more constant proportionality usually is like something else it's related to. So lots of things getting thrown out at you, but you see similar things going on. Okay, so same idea here. We're gonna look at the change in our y's or the change in our x's and see if it's greater than or less than 1/4. We're gonna do the elevator run. So if we do that, okay, comparing to 1/4 again here. On A, we bump up 3 each time, we bump up 4 each time, 3/4, okay, 3/4, okay, that's bigger than 1/4, right? 3 out of 4 is bigger than 1 out of 4, so it's not gonna be A. Remember, we want something smaller. On this one, it's gonna be down the elevator 5 over 4, so -5/4. So right off the bat, a negative is gonna be better, is gonna be smaller than any positive. So I know that the answer is gonna be B. So you could have stopped there, but again, for good measure, you weren't sure, okay? Look at the changes in your y's over the changes in your x's. 12 over 3 is gonna be a change of 4 each time. It was not smaller than 1/4. And then the last one, elevator 1, run 4, 1/4 is our slope, and that's the same. So it's not gonna be that one. So it was B on that one. So you just have to be able to look at your look at the different representations of slope and compare them, and also understand about fractions and whole numbers and negatives so that you can compare quickly and correctly.